Hello, everybody, and welcome to the Team Grothendieck weekly status meeting. Today is the 25th of April. For the last week, we've been working on transaction executions. That's the phase that we're currently in, and we've been trying to get our code complete. So there's really, I guess, two things ongoing at the same time. One is trying to get that code complete, which is we're not quite there, but we're in the process of checking in, I think, the last of it. The ECIP 1010, I think, is probably the last PR that needs to go through if it's not already through. And in parallel with that, we're implementing a test and fix cycle where we try to execute all of the transactions in the blockchain through our EVM. And as we come up against problems, we create PRs and fix them. So I'm just going to chat about, I guess, two things. One is just something of interest. I guess, Adam, you spent some time working on the elliptical signatures, and you did some investigation there. Can you tell us, just share what it is you found out?
Yes, so it all starts by realizing that the public key recovery described in yellow paper assumes that there are only two possible cases for public key recovery, but the algorithm that is used with the specific elliptic curve that is used for cryptography allows in some cases 4 public keys to be recovered. And I wanted to investigate that, why there is a difference. And while searching, I found out that those 2 additional cases that are omitted in yellow paper are actually highly improbable to occur. And even in the parity implementation, I found the comment that they're negligibly improbable to occur. So that's somehow explains why there's no recovery. There are only 2 recovery IDs for the public key. And besides that, it turns out that we also have to add some special formatting for public key encoded with the library that we used for elliptic curve cryptography, because this library, when we producing a public key to later generate the Quetzalcoatl 256 to obtain the account address, adds additional byte to the encoded point. So this is the another discovery.
Okay, and that's they're specified in the yellow paper. The 2 possibilities for those for the recovery IDs are really 27 and 28.
Yes.
Where did they come up? I mean, is that a calculation or is that just a random?
Actually, I was also looking into it, but previously, it's basically the same as in Bitcoin. So Bitcoin first came up with those numbers, and Ethereum adopted them. So those are just 2 arbitrary numbers.
Okay, and the reason that we need the recovery ID is to get the public key back from a signature and message, right?
Yes, exactly. Because for a given signature, there are usually 2, but you can have up to 4 public keys that matches with given signature.
Okay. Okay. Anyone have any? The PR that resulted from that actually was really just a refactor, right, Adam? I don't think we had to make any serious changes to how.
Yes, actually, it was refactor, and we restricted the recovery ID generation to only allow those 2 values specified in yellow paper.
Okay. Great. Does anyone have any questions for Adam on that? No. Okay, so the other thing that we've been doing is trying to get through all of the transactions in all of the blocks. So we've made several breakthroughs and then been hit by other issues as we go from successful block to unsuccessful block. Starting at 0, Radek, what is the latest news? What block are we up to?
So currently we are preparing a fix for block 299,000, but already a quick fix. I lost my connection for a moment. Did I break up?
Radek, if you can hear me, you may have to try to log back in again. The connection you've dropped altogether.
Yes, I realize. Let me start again then. So we are currently preparing a fix for block 299,000. The quick fix has been made already, and we are well past 300,000 blocks. So yeah.
Okay, and
basically,
sorry,
I wanted to.
You're going.
Yeah?
We've gone past 300,000, and is it running right now, or has it failed again?
That's a question to Nicholas, because I think he was running that.
Okay.
Yes. Well, I just created a request for the fix, and I'm currently running. The last block that executed properly was the block 320 something, and it's still running.
Okay. Well,
something.
That's exciting. We couldn't get a status that's more up to the second than that. So that is literally exactly where we're at. But Radek, I wanted just for you to share. You've done some debugging, obviously, of the problems that we run into. So can you just give us a look at some of the debug information that you're generating?
Yes, exactly. I want to share a bit of developer perspective to present how this process looks like. So let me share my screen. Okay, can you see it?
Yes, thanks.
So here I will be running our client. It's I have saved the state on a previous bug, so it will be if I run it, we should stop on block 244,000. Yeah, so let's just observe the logs. Okay, and okay, I'm stopping the application now because we can see that there was a problem. The gas used in a block was not expected. We calculated 27,000 gas for the block, but it was expected to be 42,000. And what we do in such situations, we have several levels of logging. For example, here we have traces from all the instructions executed during the execution of the transaction. Also, we have the receipt and some summary of transaction execution. So what we do is we use this very helpful tool, Live Ethercamp, and it has information about all the blocks and transactions ever performed on the chain. So here's the problematic block 244,000, and here's the sole transaction that has been included in it. So we can look at the VM traces of the transaction. Yeah, here it is, and basically we can compare well, instruction by instruction, but it's not really that scary. We usually are able to find one place when it differed, and I think in this case it was related to storing. Okay, I'm not sure. I don't want to take too much time with this because it's complicated, but basically just this information that there's 15,000 gas difference between what was expected and what was actually calculated is quite telling, and we usually have some suspicions about that. And yeah, that's what the process looks like. And also, whenever we fix such a block, we log it. We have a log of all the blocks that we found problems for, and short descriptions of the fixes. And I think it's important to see here that in the beginning, those gaps between consecutive blocks that caused problems were quite small, like 1,000 or so. And right now we are moving like 50,000 blocks at a time. So it's growing, and we're expecting to reach 1 million quite soon, hopefully this week.
Okay. Yeah. Good. That's, I guess, as you say, that's the plan, is to that we should have bigger gaps between the problems as we sort of get through the more common problems. So and we get sort of, I guess, as there's more experience, for want of a better word, under the belt of the EVM processing.
Yeah.
Okay. Thanks, Radek. Does anyone else have any questions for Radek? No, you've shown us the list of where we're at. Okay, so the only other thing to mention today, I guess, is just how we're tracking, which is roughly fine. We're trying to bring this to an end. We're in a kind of a test and fix cycle at the moment, and as you've suggested, Radek, the gaps between transactions are getting bigger, which is exciting and encouraging. But of course, it also means that we could at some stage run into some issue that really stumps us. But I think that's unlikely, and it certainly hasn't happened so far. That tool is pretty good. I guess we have to remember that it is based on the Ethereum chain and not the Ethereum Classic chain, right?
Yes, that's one risk here. That we're not sure what's going to happen when we reach the DAO fork block.
Maybe somebody will have built an explorer for the Ethereum Classic by the time we get there. Just a suggestion. Okay. So yeah, that's it. So as of for the next week, it's this week, I should say, it's same as you were. We're not sure, obviously, how quickly we're going to get through these. My hope is that the gap keeps growing, and that we'll be over 50% through the test and fix cycle by this time next week. That's the expectation, which will leave us in reasonably good shape. Okay. Does anyone else have any questions around that? I think that's pretty much all we have to communicate this week. It's more the same for the rest of this week. Okay. In that case, thanks very much, gentlemen. Talk to you on Slack.
Thanks. Bye.